Welcome to Let's Talk Meshing's Tutorial Tuesday, where we show you how to use a feature in just a couple of minutes. In this video, we're going to show you how to examine the area of elements in a domain and the volume of elements in a block. I'm going to start by selecting the domain on the surface of this blade and going to Examine Area. You'll notice that I have a color bar, and I can hover over any element in that domain and it will return the area of that element in the color bar. In this case, this quad has an area of 2.632 e to the minus 6. And I can also hover over a triangle and it'll return its area as well. Now, what if I wanted to examine the volume of an element? Well, I first need to select the block and go to Examine. And you'll notice that there are two different volume examine metrics I can look at. Let's start by looking at just volume and take a cut. And just like before, I can hover over an element and it'll return the volume of that element in that color bar. You can see the volume of this tetrahedra. And I can compute the volume and examine the volume of tetrahedra, hexahedra, pyramids, and prisms. So what's the difference between volume and component volume? Well, let's go ahead and change the examine function metric to component volume. And the component volume is going to be defined by subdividing either hexahedra, prisms, or pyramids into component tetrahedral cells. So a hex can actually be decomposed into 6 tet elements, and the volume of each tet is calculated and the minimum value is reported as the component volume. So for a tet, the volume and component volume are going to be identical, but that's not going to be the case for hexes, pyramids, and prisms. So there are a couple special cases where component volume comes in really handy. I'm going to go ahead and show you 2 hexahedra. These are in fact hexahedra, even though they don't look like it. They do each consist of 6 faces. I'll go ahead and select this hex and examine its volume, and you'll notice that its volume is positive. However, its component volume is 0, and that's because 2 of its faces are coplanar. So when we subdivide this hex into its component tets and return the minimum volume of one of those tets, it happens to be 0. Now, what about this other hex? Let's go ahead and examine that. You'll notice that its component volume is negative while its volume is positive, and that's because these 2 faces create a concavity in that hex. And when we compute the volume of the decomposed tets, one of the volumes happens to be negative, and that's the minimum value that's reported as the component volume. So the component volume is a really good metric to look at special cases like this, help you identify these situations and rectify them before you export to your solver or even look at any other examine metrics. If you like this video, be sure to click the thumbs up button and subscribe to our channel for more videos like this. And if you have any questions or comments, drop us a line down below or connect with us on Twitter, which is linked in the description. Thank you all and have a pleasant Tuesday.